Mr. Renfro, and we're going to continue on with probability. We gave you a brief introduction in the last video on what probability was. Probability is the chance of something occurring, meaning you do not know the outcome. Probability can be represented as a fraction. Fraction being the bottom number was the total outcomes. The top number was the desired outcome. So, if I wanted to flip a coin and land on heads, well, how many sides are on the coin? Well, there's a heads and there's a tails. The total outcomes for a coin are 2. If I want heads, well, there's only one of these 2 that is a head. So, it would be 1 out of 2, 50% chance that it would land on heads. Now, we're going to go one step further with this today. We're going to talk about what is the chance of 2 events happening back to back, and we'll get in what an independent event and a dependent event is in just a moment. But what is the chance of it landing on heads one time and then landing on heads another time? What would the chances of that be? Well, the way to calculate 2 events, you've been used to just doing one event, like we did earlier, a 1 out of 2 chance to land on heads, and we flip the coin once. What if we flip it? Twice? What if we flip it twice? This tree diagram shows you what could happen. Okay? The possible things that could happen. The first coin could land on tails. It's represented by the eagle on this quarter. Okay? The first coin could also land on heads, which is represented by George Washington's head there on the quarter. So the coin could land on either one. The second time we flipped the coin, let's say you flipped the first coin that was on tails. The second coin could land on tails, or the second coin could land on heads. Okay, same thing for if you flipped the first coin that landed on heads, the second coin could land on tails, or the second coin could land on heads. Now, you'll notice that this is a tree diagram. If we go all the way to the right on the tree diagram, when we count the letters going down, there's 1, 2, 3, 4 possible outcomes. 4 possible outcomes. Now, how did we get that? Well, we flipped the coin twice. So, it could land on tails, tails, or it can land on tails, heads, or it can land on heads, tails, or it can land on heads, heads. A minute ago, I asked you what would be the chance of landing on heads twice. Well, if we take the first probability, that was 1 out of 2 landing on heads, and we multiply it times the second probability of landing on heads, 1 out of 2, we get a total of 1 out of 4. Now, this is the only one of the 4 choices down here that shows heads, heads. So it's a 1 in 4 chance. We flip the coin twice because this represents the first time. This would represent the second time. This would represent the chance of those happening back to back. It's a 1 in 4 chance. One in 4. It's the only time we can get heads and heads. 1 in 4. That's it. Okay? Now, hopefully that wasn't too confusing. Let's look at some more examples. Let's go over definition of an independent event and a dependent event. Okay, first of all, an independent event, a minute ago we flipped a coin. First event was I'm going to flip a coin and see if it lands on heads. Okay? Now, when I flip the coin the second time, The first time did not affect the second time at all, because I still had the same amount of chances of flipping the coin. First time I had a 1 out of 2, and the second time I had a 1 out of 2. So nothing changed. The first event did not affect the second event. So, in my total outcome, or total chance of those happening back to back was 1 out of 4. When we multiplied 1/2 times 1/2, we got 1/4. Okay? That's called an independent event. The first event does not affect the second. Dependent event is when the first event, typo there, the first event affects the second event. Now, what do you mean by that, Mr. Rick? Well, let's take these coins in a circle. Okay? We've got a group of coins in a circle. We've got 2 nickels, 3 dimes, 5. Okay? If I asked you to reach in, let's pretend that circle's a bag. If I asked you to reach into that bag, pull out a coin, what is your chance of pulling a dime out? Let's change it. Let's say a penny. Let's say, what is your chance of pulling a penny out? Well, your chance of pulling a penny out, well, how many coins or total coins are in the bag? Total coins is 10. Okay? The desired, what did I ask you to pull out? What's the chance of pulling a penny? How many pennies are in the bag? That would be 5 out of 10. So your chance of pulling a penny out the first time is 5 out of 10. Okay? 5 out of 10. Now, so I pull the penny out of the bag. Okay? Pull the penny out of the bag. Now, if I asked you what's your chance of pulling a penny again for a second event out of the bag, what would you say your chances are? Well, how many things are in the bag now? There's 1, 2 nickels, 1, 2, 3 dimes, 1, 2, 3, 4 pennies. Now the chance of the second event, there are only 9 possible outcomes, or 9 things that could be pulled out. Now how many of those are pennies? Well, I pulled 1 penny out, so how many's left? 1, 2, 3, 4. So it's 4 out of 9. So you can see here that what I did the first time by pulling that penny out affected the second event. When you do that, that's called a dependent event. And you'll notice that the denominators change. A minute ago, when I flipped the coin, and I did 1/2 times 1/2, the denominators didn't change, and they ended up with 1/4. Now this time the denominators did change. So let's go ahead and multiply this out. So the chance of me getting a penny the first time was 5/10. I did not put the penny back. I did not replace it. Because I did not replace it, the second time there were only 4 pennies in the bag and only 9 total coins. So that ended up being 4 9s. When I multiply that, total chance of me getting a penny both times without replacing the first penny would be 20 out of 90. 20 out of 90. Okay, that. Understood that. We'll do a few more examples here. Okay. Now this time, let's start all over again. Put the penny back. Let's try the same scenario. Let's say I want to pick a penny out of there again. Well, how many total coins are there? 10. How many total pennies are there? Or desired pennies? Desired outcomes. There's 5. So, that's the first time. So, I took the penny out. This time, though, I'm going to put the penny back. Penny back. So, again, I'm going to ask you the question. What's the chance of getting a penny the second time I reach the back? Again, it's going to be 5 out of 10. Now, when I multiply those 2 events, the first event times the second event, I get 25 over 100. Now, this is an independent event. It's independent because I put the penny back. I replaced it. I put it back in the bag. And my denominators didn't do what? They did not change. So, the first event did not affect the second event. So, let's try a different scenario. Alright, let's say this time I want to pull a nickel out. Well, again, there are 10 coins in the bag. Okay? How many nickels are there? There's 2. So I have a 2 in 10 chance of getting a nickel when I reach into that bag. Well, I'm going to take the nickel out. I got the nickel. I'm taking it out. So the second event, what is my chance of getting a nickel? Well, there's only 1 nickel in the bag. So that's going to change to a 1. And how many coins are in the bag? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. So the bottom number is going to change to a 9. When I multiply that, numerator times numerator, I get 2. Denominator times denominator, I get 9. Now, what did you notice? You notice that the denominators changed. The first event affected the second event. And I took this nickel out. I took that nickel out, things changed. The probability of me getting what I wanted changed. So that is a dependent event. Okay, let's try it one more time. This time we'll do an independent event. All right, put the nickel back. All right, what's my chance of getting a dime? What's my chance if I do the dime one time? If I reach in the bag one time and try to get a dime, it's going to be 3 out of 10. Because there's 1, 2, 3 dimes. Okay? Now, let's say I get the dime I want. Well, I get the dime I want, then I replace it. I put it back. So, the second time I reach in there and I want a dime, there's still 10 coins in the bag. And there's still 3 dimes in the bag. So it's still a 3 out of 10 chance. I multiply that first event times the second event. And I get 9 over 100. This is my total probability of doing these 2 events back to back by replacing the coin. This is an independent event. It's independent because the first event did not affect the second event. It stayed the same. Try one more dependent event. Hopefully you're catching on to this. Okay? Dependent events. Alright? Remember, the first event will affect the second event. So, what is my chance of pulling a dime out? Well, just said it's 3 out of 10. 1, 2, 3 dimes in the bag of 10 coins. So, I pull that dime out, and I do not replace it. Then I pull from the bag again. The second event, how many coins are in the bag? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9 in the bag. The bottom number has to be 9. And how many of those are quarters? Excuse me, dimes. 1, 2 dimes. Okay, so that's why the top number would be 2. Now, when I multiply that, what's the chance of those 2 events happening back to back? That would be 6 out of 90. 6 out of 90. 3 times 2 is 6. 10 times 9 is 9. What type of event is this? This is called a dependent event. Because the first event affected the second event. And you can tell that by the denominator change. It went down. It's no longer the same probability. So let's do a real quick review. All right? Started off with talking about independent, dependent events. And I started out by saying, what is the probability of a coin being flipped twice and landing on heads twice? Well, we use this tree diagram to illustrate that the total chance of you getting heads the first time and you getting heads the second time is 1 out of 4. Because the first event you had a 1 in 2 chance, as illustrated right here. In the second event you had a 1 in 2 chance. And when you multiplied those 2 together, you had a 1 in 4 chance of getting heads and heads, or illustrated right here, heads, okay? Then we went to the coins in the bag, and then I started telling you what is the difference between an independent event and a dependent event. Well, the coins in the previous slide, heads was an independent event because there was a 1 out of 2 chance of getting heads the first time you flipped the coin, and a 1 out of 2 chance of getting heads the second time. So nothing changed. So you wanted no chance of getting what you wanted. Back-to-back heads. We went and we talked about the coins in the bag. Saying it matters whether you don't replace the coin or if you do replace the coin. If you replace the coin, then that's an independent event. If you do not replace the coin, then that is a dependent event. Because the first thing affected the second. Again, I hope this has been helpful, and I hope that if you are having any trouble with this, that you watch this video